Greetings to you all. My name is Takuwani Ramagwede, and I'll be presenting you with my findings from the regression predict all the Zindi challenge that we have been given. So the problem that we have been given is that there's a company called Sendi in which it deals in delivering products. And this company has got data, and my task was to use the data in order to build a model in which it can predict an accurate delivery time from picking up of the package to the arrival of the destination. So one of the findings that I found, or one of the things that I found by looking at the data or the correlations was the predictor variables that had a strong correlation with the Y data, or with the time from pickup to arrival data. And I've noticed that the predictor variables that had a very strong correlation were with regards to distance and geographical locations, such as latitude and longitude. This actually makes sense because usually time of travel uh, is normally determined by how far the distance, or how far a person is going, or where they're going, although there are other factors that can come in as well. So one of the ways that I approached this, my pre-processing, was I initially checked for columns that had missing entries and checked the type of data that each columns had, and columns that had missing entries of 25% of the total length of the column, I decided that I'm going to drop, and those with less I kept and decided to swap the null values, or to replace the null values. So I dropped precipitation in millimeters. It had very little non-null entries in it, but decided to keep the temperature and just used mean to swap those values. Then the next thing, I proceeded into using variable selection methods to further drop columns that, or features, or variables that are not needed and that would have not impacted our model that well. And then one thing that I found interesting was just the data coming from the riders CSV, uh, such as average ratings and number of orders, as you can see in this red box here. And these things had a p-value of less than 0.05. And basically how I got them into the train and test data was I joined them there, and I was able to do so because the train and test data, as long with the rider CSV, has got a rider's ID, so I was able to match them in that way. And basically, after the pre-processing and adding that extra data and removing variables that were not important, I ended up using a random forest regression, and this was the one that gave me an RMSE of 765. This was my best as I was doing all of this, and this was after using all the other models of linear regression, decision tree, and ridge. I think that this model could have been improved by better variable selection, checking for variable significance, and improving on train and test of the data, which I didn't do any because it had already come in, it was already split. And I'd like to thank you for your time, and